The image was uploaded to an obscure, deeply nerdy corner of an audio forum late on a Tuesday night. It was grainy, poorly lit, and clearly taken in a rush with an older smartphone. It showed a dusty, intimidatingly complex black metal box sitting on a cheap plastic folding table, right between a stack of faded romance novels and a rusted set of golf clubs. Slapped carelessly onto the brushed aluminum faceplate of this machine was a bright neon green garage sale sticker. It read, simply, $15. To the untrained eye, to the person who priced it, and probably to 99% of the people walking past that folding table, it was just an obsolete piece of 1980s junk. A bulky cassette player destined for the local landfill, a relic from a time before Spotify, before iPods, before CDs even truly took over. But the forum comments were in an absolute, unmitigated meltdown. Users were frantically typing in all caps. Some were demanding to know the exact GPS coordinates of this driveway. Others were accusing the original poster of faking the image just to cause a riot. Because the people on that forum recognized the silhouette of that black box, they knew exactly what had just been purchased for the price of a fast food combo meal. It was a Nakamichi Dragon, a mechanical masterpiece of audio engineering that regularly commands upwards of $5,000 to $7,000 on the collector's market today. This immediate jarring mystery begs a very simple, very logical question. Why would anyone in their right mind pay the price of a reliable used car for a tape deck? A machine that plays a format most of us abandoned decades ago? The answer to that question lies much deeper than mere sound quality. It lies in a completely forgotten era of technological history. An era where engineers, not corporate accountants, not marketing focus groups, but brilliant, obsessive engineers were handed blank checks. They were given a mandate to build absolute monuments to sound, regardless of the cost, regardless of the practicality, and certainly regardless of the weight. We are living in an age of disposable convenience. We don't really own our technology anymore. We just lease it until the battery degrades. We buy pristine, beautifully packaged white wireless earbuds. We accidentally drop them in a puddle 2 years later. We shrug, and we buy another pair without a second thought. Our relationship with hardware has become entirely frictionless and completely devoid of emotion. But there was a time, a brief, glorious window in the late 20th century, when audio equipment was engineered with the ruthless, uncompromising intensity of military hardware. This is a journey into that specific age. An age of limitless, unapologetic, and sometimes deeply, tragically flawed engineering. The Mark Levinson, number 33. To truly understand this mindset, we have to look at the leviathans that roamed the earth during this period. And there is no better starting point than the Mark Levinson number 33 amplifier, born in the uncompromising high-end audio boom of the 1990s. To call the number 33 an amplifier is a bit like calling a nuclear submarine a boat. It is technically true, but it wildly misses the point. When you look at this machine, it does not look like a piece of consumer electronics meant to sit quietly on a TV stand. It is an imposing, monolithic aluminum fortress. A single unit weighs well over 200 pounds. And because it is a monoblock amplifier, meaning it only handles one channel of audio, you need two of them to listen to music in stereo. That is nearly half a ton of raw, heat-generating metal sitting in your listening room, each unit arriving in a shipping crate that itself tips the scales past 400 pounds. The sheer logistical arrogance of this machine is staggering. Before you could even think about plugging it in, you had to call a structural engineer. Owners literally had to reinforce the wooden structural joists of their living room floors to prevent the amplifiers from crashing through to the basement. You couldn't just plug them into a standard wall outlet either. They required dedicated, high-amperage power lines installed directly from the breaker box, the kind of electrical infrastructure usually reserved for industrial welding equipment. But why? Why go to these absurd lengths just to amplify an audio signal? Because the engineering obsession here was the pursuit of a mathematically perfect universe. The designers of the number 33 believed that the electricity coming out of your wall was inherently dirty. It was polluted by your refrigerator compressor turning on, by your neighbor's air conditioning, by microscopic fluctuations in the power grid. To an obsessive engineer, that dirty power introduces distortion. So, the number 33 simply refused to use the wall power directly. It took that incoming electricity, converted it to DC internally, and then used it to drive a precision oscillator circuit that generated its own brand new, mathematically flawless alternating current from scratch, right inside the chassis. It was a self-contained power station dedicated solely to the purity of a single audio note. Yet, for all its godlike power and architectural majesty, the number 33 harbored a tragic, almost poetic fatal flaw. Deep inside this aluminum fortress, buried under layers of custom-tooled heat sinks and massive transformers, were certain electrolytic capacitors sourced from outside suppliers. And over time, these specific capacitors were prone to failure. They could leak, overheat, and in some cases rupture, quietly destroying the immensely expensive, irreplaceable circuit boards from within. When a number 33 inevitably broke down, the owner wasn't just facing a repair bill. They were facing a logistical nightmare. You can't just put a machine of this size and weight in the trunk of your sedan. It required custom wooden shipping crates, freight pallets, and a specialized shipping company to move hundreds of pounds of dead metal across the country to a qualified technician. It was the ultimate irony of the era. A machine built to the most exacting electrical standards on Earth, brought to its knees by an off-the-shelf component, a monument to obsessive perfection, undone by ordinary entropy. The Nakamichi TX 1000. But raw power was only one side of this blank check era. If the Mark Levinson was an exercise in brute force, our next machine is a study in beautiful, unhinged mechanical precision. The story smoothly transitions from the heavy lifting of amplifiers to the delicate, microscopic world of vinyl records with the Nakamichi TX 1000 turntable. To understand the TX 1000, you have to understand a problem that practically no normal human being would ever notice, let alone care about. When a vinyl record is manufactured, a machine punches a hole perfectly in the center so it can sit on the turntable spindle. But in the real world, physical manufacturing is never perfect. Very often, that center hole is off-center by microscopic fractions of a millimeter. To you and me, this means absolutely nothing. But to the engineers at Nakamichi, this was an unforgivable crime against physics. When a record is slightly off-center, the tone arm sways gently back and forth as it tracks the groove. This swaying causes the speed of the music passing under the needle to fluctuate ever so slightly, creating a phenomenon known as wow and flutter. A sustained piano note might sound just a tiny bit unstable, like it's warbling underwater. A normal company would just tell the consumer to buy better records. Nakamichi decided to build a machine that defied reality instead. When you place a record on the TX 1000, you don't just drop the needle and listen. You initiate a sequence. First, a hidden, secondary robotic arm emerges from the chassis. This isn't the arm that plays the music. This is an inspection arm. It swings over to the innermost groove of the record and gently drops down. The turntable begins to spin. As the record turns, this robotic arm measures the exact microscopic deviation of the off-center hole. We are talking about tolerances invisible to the naked eye. Once it calculates the error, the magic happens. A sophisticated motorized mechanism underneath the platter physically nudges the record platform along an X and Y axis, shifting it a fraction of a millimeter until the groove of the record is absolutely, mathematically centered around the axis of rotation. Only then does the robotic arm retreat, allowing you to actually play the music. It is a machine designed to physically correct the manufacturing flaws of the media it is playing in real time before a single note is heard. It is a level of mechanical over-engineering that borders on absolute madness. It is solving a problem with a sledgehammer of precision simply because they had the budget and the brilliance to do so. The Sennheiser Orpheus. But what happens when this obsessive engineering culture collides head-on with the efficiency-obsessed corporate world? You get the ultimate clash of ideologies. You get the 1991 Sennheiser Orpheus. In the early 90s, the executives at Sennheiser wanted a flagship product. They wanted a high-end headphone that would showcase their technological prowess, generate some good press, and ultimately, be a highly profitable luxury item. They handed the project to their engineering team. The engineers smiled, took the budget, locked the doors to the lab, and delivered something that absolutely terrified the accounting department. They didn't build a consumer product. They built a system that belonged in a museum. The Sennheiser Orpheus model designation HE90 and its companion amplifier, the HEV90, was not just a pair of headphones. It was an electrostatic system of terrifying refinement, anchored by a dedicated vacuum tube amplifier. The headphone drivers used platinum-coated diaphragms, just microns thick, suspended between gold-coated glass electrodes, vibrated by electrostatic forces rather than the crude push-pull of a conventional magnet. The tube amplifier that drove them was a meticulously hand-assembled piece of electronic craftsmanship, built to deliver the extraordinarily high voltages that electrostatic transducers demand. The Orpheus was a commercial absurdity. Nakamichi produced only 300 complete sets. The cost of sourcing the specialized electrostatic driver components, the painstaking hand assembly required, and the failure rate of the precision amplifier circuits made it a nightmare for anyone trying to run a profitable business. It sold for approximately $15,000 at launch, an almost incomprehensible sum in 1991. And yet, it became the undisputed holy grail of the headphone world precisely because it refused to compromise. It was a giant middle finger to the concept of cost-cutting. It existed simply to prove that perfection was possible if you were willing to bleed for it. That spirit of theatrical excess would be revived and pushed even further when Sennheiser's engineers were handed another blank check more than 2 decades later to build the Orpheus's successor. The result was the 2015 HE1, an amplifier chassis carved from a single block of Italian Carrara marble, the same stone Michelangelo used to sculpt the statue of David, activated by a physical metal key that caused vacuum tubes to rise silently from the marble block on hidden precision motors, glowing amber as they reached temperature before a glass lid lifted automatically to offer the headphones. 2 generations, one unbroken obsession, the Nakamichi Dragon, which brings our narrative full circle. Back to that dusty folding table, back to the $15 garage sale find, the Nakamichi Dragon. Why did a cassette deck cause a forum of grown adults to lose their minds? Why is it worth thousands of dollars today? If we visually strip away that black metal casing, if we look past the fading neon price tag and peer into the guts of the machine, we don't see circuit boards and microchips. We see an impossible mechanical ballet. Cassette tapes, by their very nature, were deeply flawed. The tape itself is just a thin ribbon of magnetic plastic being dragged across a metal playback head. Because cassette shells were cheaply made, the tape would often wander. It would shift slightly up or down, losing its perfect perpendicular alignment with the microscopic gap in the playback head. In the audio world, this angle is called azimuth. If the azimuth is off by even a fraction of a degree, the high frequencies vanish. Cymbals sound like mush. Vocals become muffled. Every other cassette deck in the world just accepted this flaw. You put the tape in, and you got whatever muffled sound the cheap plastic shell dictated. The Dragon did not accept this. Philips engineers had originally conceived the idea of automatic azimuth correction, but it was Nakamichi who transformed that concept into a working production reality. The engineers at Nakamichi deployed a proprietary motorized playback head. When you press play on a Dragon, the machine doesn't just spin the tape, it listens. It constantly analyzes the phase relationship of the high frequencies across a split-gap playback head. If it detects that the tape is drifting out of alignment, a tiny precision motor physically adjusts the angle of the playback head, tilting it microscopic fractions of a degree, continuously, in real time. It is constantly hunting for the absolute perfect azimuth alignment. It is a tiny mechanical brain making real-time physical adjustments to a moving piece of magnetic tape to extract a level of fidelity that the format was never designed to deliver. It is the pinnacle of mechanical audio engineering, a monument to the idea that a machine can physically conquer the limitations of physics. What we have lost. When we look back at these machines, the 200-pound aluminum fortresses, the robotic turntables, the electrostatic wonders, the marble monuments of a later era, and the self-adjusting tape decks, it forces us to reflect on what we have lost. Today, our technology is undeniably smarter. It is faster, it is infinitely more convenient, and it fits in our pockets. But it is also entirely soulless. We are surrounded by sealed glass rectangles held together by industrial adhesive. When a modern laptop or a smartphone breaks, it is practically a death sentence. It goes into a drawer, and then it goes into the trash. But these incredibly heavy, wildly over-engineered machines of the past, they demand respect. When an Orpheus or a Dragon breaks down today, they aren't thrown away. They are carefully packed and sent to specialized gray-haired technicians who operate out of cluttered workshops. These technicians will spend months tracking down rare, new old stock parts, meticulously soldering connections, and recalibrating mechanical tolerances. They treat the repair not as routine maintenance, but as a resurrection. They are waking up a sleeping giant. Because they know that machines built with this level of passion, this level of insane, uncompromising obsession deserve to survive. So, the next time you find yourself wandering through a dimly lit thrift store, or walking past a folding table at a neighborhood yard sale, take a moment to look a little closer at the heavy black boxes gathering dust in the corner. Don't just dismiss them as obsolete junk. Look at the weight of the metal. Look at the precision of the dials. Because buried under the cheap plastic junk of the modern world, sitting right next to the rusted golf clubs and the faded paperbacks, there might just be a forgotten mechanical leviathan waiting to be woken up, and it might just be worth a fortune.